All right, so find your way to lesson 6 of the current unit. And for those of you strolling in late, the missed portion that you missed was about showing up caught up, and it's your responsibility, and it doesn't get better on its own. You have to stay caught up. All right. Okay. So here we are, lesson 6, as I try to use 2 mouses at the same time. All right. So far we've done basic turtle programming, where we have the turtle drawing all over the place, but in a pretty tedious, lots of move forwards and move backs. And then we got the use of functions. Okay. Functions on the short list of super duper important concepts, like a list of 4 or 5 major things that you need to understand and use. And it is functions, which are, the analogy is the, like, I don't know, football playbook. You need to draw up the play. And this is, even if you don't know sports, you should understand the concept of a playbook. That seems pretty universal. You have to first draw up the play, and then you need to call it, during the game. Both things need to occur. And that's what how a function works. You need to write the definition. You need to define the function, and then you also need to, use it. It is also a good analogy as a tool in a toolbox. You must first acquire the tool and then use it. Okay. So we're going to use functions to work on top-down design, or different ways, different design, problem-solving techniques. And it will be an example of abstraction. Last time we did the draw diamond, which we did bottom up. We started with the smallest portion and kept building from there. And now we're going to do the opposite. We're going to start with the largest component and work our way down. Now, the problem with that, and you'll see, is you can't really test it as you go. Okay, and you'll see. Okay, so abstraction are layered, simplification, solving one problem and being done with it. Function, we've talked about that. We aren't going to do the worksheet. We're just going to jump right into the programming, and which you can thank me on that later. It is essentially just the programming, but you do it on paper and then you do it on the computer. And yeah, like I said, top-down design. Okay, so let's go on to bubble 2. And I'm not sure if it's clean for me. And again, full screen never hurt anybody. All right. So let us start from the beginning. And is this I think this is a 1 bubble project. Okay. So here's what we need to do. Welcome. Here's what we need to do. So, okay, so you should already, we're not doing partner stuff. Don't worry about it. Okay. Here we need to start with the top level, okay, and look for patterns that will make their own function. Okay. Your functions obviously will be calling other functions, and descriptive and meaningful names, and your program should be kicked off with a single function call. Okay, so this one and a lot of other lessons, there's not a ton of sort of independent creativity, but the idea is, and I'll get you sort of started. Well, first of all, generally a good idea to put some white space in there so that you can organize it. Please put white space in between your function definitions. You'll see. Okay, so first one, we're going to have our top level function. top level being not, I mean, the most simplified, but the one that uses the other solutions. And let's go ahead and call it, well, I don't really want everything to be draw, draw diamond, draw side, draw whatever. So let's just call it diamond. Okay. And in order for diamond to work, oh no, wait, not diamond, snowflake, my mistake. Okay, that is the name of the shape. Okay, snowflake, we can, in order for it to work, we need to call it. And this process of sort of starting at the top level, it's really sort of calling your shot because you can't really test it as you go. We are just calling snowflake. Snowflake doesn't exist yet. Okay, we are confident in our ability to make it happen, that we're going to go ahead and call it. Okay, so snowflake is the top level problem. Now, you could break it into smaller, well, you have to break it into smaller problems, but you could break it into a couple different ways. We could say there are 4 of this shape, this cross shape, for lowercase t. There are 4 of them, and we could set up our program to run cross. This is just an example, and I'll give you a different example and then let you go. Okay, so we could have snowflake draw cross 4 times, in which case we would need to define cross, okay, and then figure out what each cross is made of. That's one solution. Another solution would be to make a function that makes one of these, and the entire shape is made up of 5 of these. So we could call it draw plus, or just plus, or plus sign, I don't know, make up a name. Plus sign. Also, this is your first time we talked about naming conventions for functions, and the rules generally are you have to start with a lowercase letter, and you can't have any special characters or spaces. You can put numbers in it somewhere, and we tend to use what's called camel case, which means new words are with a capital, and that's how you would read multiple words. I think you can use underscore, but it doesn't have to be camel case. You could just spell it. In fact, it could be anything technically, function names and variable names and stuff. It doesn't matter what it is, but it needs to be meaningful and descriptive. So what did we call this? Plus sign. And we would need 5 of these. 5 plus signs. And there would probably need to be a move forward or something here. Did I make 6? I made 5. Okay, so this is where I'm going to let you go, where the idea, of course, is working your way down. If you were doing the plus sign, you would then need to write the function, the combination of move forwards and turn lefts, which you probably could get the use of a move forward, double left, move forward tool. And depending on how you implement that, that would probably be a useful function. Let's call it out and back. And that would be a forward, a double left, and another forward, which, depending on whether you're doing cross or plus sign or something else, this would be a useful tool because it can be used lots of different ways. Okay, like you get your turtle to this point and do an out and back, and out and back, and out and back, and an out and back. And that will get you to there. And then you just need to find your way to the next spot and do an out and back, an out and back, an out and back, and an out and back, and so on. So you're building your toolbox of useful things as a way of solving this. Okay, so I'm going to give you a good amount of time to work on this, a medium amount of time. Like, let's see what 8 minutes does. Okay. So you are working your way down to the smallest components of this. I will be watching along on your machines. Please do that. Also, I'd like to do some, we'll just go ahead and work on that for now. If you have a charger, you can, if that's keeping you from being productive, you could plug it in right here. Or if you're working, that's fine.
Why don't you just make it like that? Why don't you just first make the cross, right? Go up like this, and back, go straight, turn again this way, straight, come back, and then go back. Then turn around, make a function, and then you can come in here, and then here, see through, I don't think so, but turn here, right? Turn here, and go straight down, right? And then you're facing downwards, so you do, and then you just place the cross function again, and then you come up this way, and then you just do that cross function, and then turn. What did you say for years? Like, no, not really. Up at the top. Okay. Wait. Okay. I think I see what. Okay. It's really. I would do it. Okay. Right? It's three like.
I had it muted the whole time. It's kind of a strange concept that we have something that works exactly how we want it to work, but we're still going to refactor a few things. Generally speaking, if you have something that works, it works. But as in the goal of efficiency and problem solving, you'll notice we have forward, forward, left here, and forward, forward, left here. Okay. That might be enough to justify an entire another function. Okay, so the forward, forward, left just does that first step to get it ready for the out and backs. So let's just call it, I don't know, setup or reset or something like that. I don't know if reset is a reserved word. How about reset 1? Something like that. And then all we need to do is put our forward, forward, left in there. Folks, this is important. Okay, so reset 1 is going to replace, let's just copy this. Okay, folks, do listen, even if you're flying through. That means like hang out on the other short answer stuff. Excellent. Okay, once again, for those of you, just go ahead and take a look at one of the screens that's doing stuff. Excellent. Okay, so we have this series of code, forward, forward, left here, and forward, forward, left here. If we make a function that calls that is that, we can replace this with a call to that function, which I've named a reset 1, just because. And the same thing here. Because it's called a few places, it makes sense to make it its own function, similar to the process for finding good compression stuff when we did the text compression thing, where you want something that's used a lot, and the more it's used, the more useful it is as a function. Okay, so there we go. We've broken it into smaller components, and we are good to go. All right, let's go on to bubble 3. No, that's not what I want. I want this, and I want this. And why does it not work? It never works. All right, well, if that doesn't work, it doesn't work. Okay, so our goal here is the same basic idea of starting with a top-down. I really refresh it. A top-down pattern of drawing this grid. Okay, and if you recall from when we did it before, the best path was doing these sort of longer lines, but that probably isn't going to be the best path for now, because we have the ability to write functions for smaller components and then call them multiple times. So it actually will be less code to do it the way that's intended. But I'll get you started, and let's have, well, first let's for white space, when we start, just go ahead and switch to text mode. When you're in text mode, put a bunch of lines in it, and then do / twice. That is a comment, and that will force it to create blocks when you switch back to block mode. Please don't just hit enter a bunch of times and have your white space be these semicolons, because then you have unnecessary yellow things and it's just ugly to look at. So don't do that. Okay, so again, we're starting from the top down. Let's go ahead and call our final function grid. Boom, there is our final function. We need to now define it. Okay, so we need a function definition for grid. And well, what's a smaller component than the full grid? A row or a column? Your choice. It doesn't really matter. Okay, maybe row or row, depending. Okay, and draw row 3 times because there are 3 rows, or draw column 3 times. Doesn't matter. But we now have a function called to a function. We have a call to a function named row. We need to define row. Okay, and that's where I'm going to leave you for a few minutes. A good hint, or maybe just give you an extra help, is you are probably going to want to make a right turn at some point here, and we don't have access to turn right yet. Let's go ahead and make a tool called right. I'm not sure how it's going to be used yet or where it's going to fit, but I know at some point I'm going to want to make a right turn. So now I have a function called right, and it's like I have full right turn privileges at this point. Okay, so let me give you a few minutes and you can take a shot at it. Okay. Proceed.
When I do this space. Like, okay, with this, no problem. I don't know.
Uh-oh. Uh, anything over there. Take whatever you need.
If you make the turn right function called.
Still good to talk about reserved words and stuff like that. Syntax. What's up? From where it starts, the grid needs to be up this way. Because you can see where it starts. It starts. Of course.
So, Jeremy read it. You guys.
Thank you.
Jeremy ran into the moves, okay? Tyler. Party and. Ready? 3, 2, 1, go. there. Oh, Jack. Oh, Zach, where are you? All right. Oh my gosh, I don't think I'm in the race. Yeah, that's definitely. All right, look at it. All right, wait for Ross Johnson to see if it's right. I don't think you can at least do it. Yes, there is. All right, let's try. Yeah, let's try. All right. Dwayne Johnson. Dwayne Johnson. Dwayne Johnson. You ready? Wait, you're starting at check. Okay, I'll do it. You ready? Hold on, we can check them. All right.
Let's go ahead and do this. No. Why don't you go back to the work for this class and pay attention and make sure yours looks like mine to some extent. All right. Let's keep going. All right. So we've got a grid, a function to draw the whole grid. Lovely. Done. Okay. And my plan is to make the grid up of 3 rows. Okay. But once again, we need to plan ahead that each row needs to finish. Well, I'm going to start with a triple right, or excuse me, a triple left to turn right. Okay. If you recall from the last one, it was easier. Well, now that we have a right turn, it doesn't really matter, I guess. But I still think of things in terms of starting from the right. So let's go ahead and start with a right turn, okay? Because I know, well, no, yeah, that's fine. Okay, so let's start with a right turn. And that'll get us pointing east at the origin. And then our row is going to be made up of draw block or draw square and be ready for, it's going to be draw square or draw box 3 times. But if we call it 3 times, it's going to be here, and we need it to be ready to be back here. So at the end, we're going to need another left, a triple forward, and a U-turn, which might be useful to be its own function, because when we get to the end of the second row, which the second row will be like this, when we get to the end of the second row, we'll be over here pointing this way, at which point we need to get back to here to do the third row. Okay, so just something to think ahead, that row needs to end with a reset. But other than that, row is just going to be draw box 3 times, because there are 3 boxes in each row. Okay, and I like my right function a little lower because it's like the lowest of them. And draw box. What is draw box? Well, draw box is just forward, left, forward, left, forward, left. but forward, left, and a total of 4 forwards and 4 lefts alternating. And let's see what row looks like. Okay, I'm going to turn off my grid call so it doesn't call to grid, but I am going to call just one row and let's see what happens. So row makes 3 squares, but on top of each other. And the reason why it's on top of each other is it always comes back to the same start point. That's what happens with 4 times around a square. So we need an extra move forward at the end so that it advances. Oh, nope. Where do we put forward, left, move forward, turn left? No, where's the extra one go? At the end. No, it goes in. Wait, why would it be there? After the box, left, move. What happened? Why do I have, okay, forward, left, forward, left, forward, left. Do I need one less? Why does this look weird? Yeah, I think that's right. Okay, so it's not, let's see what happens. 3 boxes. Yeah, there we go. Nope. What is, okay. I want forward, left, forward, left. No, where am I? Forward, left, forward, left, forward, left, forward, left, and an extra forward. So forward, left, forward, left, forward, left, forward, left. Oh, that's what I had. Okay, 1, 2, 3, 4, and an extra forward should. Why is this happening? Forward, left. Okay, we're already turned to the. It's because I never called the right turn. That's why. Okay. Forward. There it is. All right. So we're pointing east, and we've got a function for a box, which isn't just 4 forwards and lefts. There's an extra forward at the end so that it advances to the next square. All right. So we can go back to drawing one row that starts with a right, and we'll call our full top level function. Okay, so we have grid, which starts with a right turn and then draws 4 rows. Each row is 4 boxes, but we need row to end up at the ready for the next one. So right now, each row ends there. So we need at the end of row, we need an extra left turn, an extra move forward, and I have a feeling this is going to be its own function shortly. An extra left, a triple move forward, and let's see where that gets us. Move forward, and it gets us to there. We need a turn right, or a double right, or double left. We need a U-turn. Okay, and so that gets us to 3 boxes and gets us back to the beginning, which means we can now just call row 3 times or twice more. And we'll speed it up so we can get to the end. I think this should work. And that gets us to there. And to get back to the origin at the end of grid, let's do a right turn. What's that? I'm using right to start the function. I'm going to go back and, well, I don't have a triple left. I'm going to go back and refactor. I just want it to work to start. Okay, so this gets us to, where does this get us to? Top there. Okay, I need a right turn. Oh, I do need that. I need a call to right. That puts me pointing south. I need a triple forward, which when we're done, we'll look at stretches of blue that are repeated and a double left, but at least this will get us there. 3 rows with a little reset at the end. Okay, and then let's see, do we have some patterns? I have a triple forward and a double left. Do I have okay, I have another triple forward and a double left. It's probably worth making another function over that. So let's just call it setup or reset. How about setup? And setup is just going to be the triple forward double left because that happens a couple times. Then it's worth it. So anywhere that we have triple forward double left, we can replace it. So that's one place that it exists, and that's another place where we just need to call, what do we call it? Setup. There's one called to it, and there's another. Okay, and that's what you saw there is the general concept of a function where you're replacing chunks of code with a single tool that solves it. Okay, now we're only using setup twice. I suppose we're only using write twice as well. There'd probably be a better way, a slightly better way to do it, but this is pretty good. Okay, let's work on the wrap-ups. Okay, so any of the checks for understandings that talk about AP practice, they are references to the project that is in the spring that everyone is going to do that is part of the grade for this class. But if you're taking the AP test, you will then upload it as part of your test grade. Regardless, the practice is for the way the test used to be, where you would write out, okay, just a quick overview of the project. You're going to write your own or create your own app with specific requirements. It doesn't have to be complicated. They'll be very clear what you need to do, and there'll be plenty of time to do it. But part of the old way of doing it was your written responses about your app would be written in class or before the test, and you upload that with the project. Now you submit your project, but the written responses are done on the test or like on test day, and you write about your app. But these are still essentially the prompts that you will have, except writing on the test. Well, one of the possible ones. And the rubric is still very similar, how they do things with rows as the defining grade, whether or not you earn the point for the row. And, yeah, good luck if you're not listening. And so the question here is about describing incremental and iterative development process, meaning baby steps and steps. Okay, focusing on two distinct points in your process. Okay, so this is a relatively simple app that we designed, and it's hard to discuss like major design difficulties, but yeah, try your best. Okay. Okay, yeah. So iterative process and reflecting feedback. These are the prompts. Write about your 3x3 grid. Okay, and bubble 5, top-down design. This is talk about this just as like you would for the snowflake or the diamond or the grid, where you're coming up, and at this point you don't actually need to program them, but just what would you call the functions, assuming they are descriptive names of what's happening, in order to draw this. Okay, if we're talking top down, I would say, what would you even call that? S. Like my first function might be draw S. Okay, and then draw S might be draw a line, which would be 6 forwards. Okay, or something like that, and keep breaking it down into smaller components. Okay, bubble 6, multiple choice. Which of the following statements about writing functions and top-down design is not true? And the last one, bubble 7. Okay, in the create performance task, you'll be asked to identify an abstraction in your program and explain how it helps manage complexity. Okay, this phrase of manage complexity is something you'll see a lot. Please listen. Managing complexity is something that is like the concept of abstraction, where you solve a lower level problem and then you don't have to worry about it. If our program code didn't have abstraction, if it didn't have functions, this function grid would be, or just if we were just using turtle things, it would be 100 or 200 lines of blue turtle movements. And that is definitely not what we're looking for as far as managing complexity. Okay, functions are a form of abstraction. Pick a function you wrote in your solution to the 3x3 square problem and explain how it manages complexity. Okay, so go ahead and knock those out. That is the extent of instruction. Everything there is due today. Today is the due date for this stuff, even if it's not graded today. And that's it. Go for it. Let me know if you have any questions.